Greetings. My name is Ishan Kshirsagar and I am the leader of the team Code of Duty 405 for Smart India Hackathon 2022. Our topic is to identify monuments from satellite images using deep learning and integration of interpretability for the predicted outcome. This problem statement was provided by ISRO. A monument is a physical structure built or created that is dedicated to a person, event, or purpose. Monuments become relevant to a group as a part of their history or culture due to their artistic, historical, political, technical, or architectural importance. It has become a necessity to identify and preserve information regarding monuments and landmarks digitally in today's world. There is a need to digitally recognize and archive the monument as an important historical and cultural heritage site. This poses as an impactful feature not only for the tourists but also for the local people in order to gain knowledge regarding their own cultural heritage. One of the ways to achieve this feat is by using deep learning. But what exactly is deep learning? Let me provide a simple analogy to explain how it works. Suppose you're a student and you have to prepare for an upcoming exam. Say you have a question bank. For the preparation, you read both the questions and the answers. In the exam, however, you are only provided with the questions, but at that point, you are trained enough to come up with your own answer. This is also how a deep learning algorithm works. Here, the student is the model, and the question bank is the data set from which the model trains itself enough to predict the outcomes for any given input. A deep learning algorithm has a certain sequence of steps to be followed. These are: first, exploring and pre-processing the dataset. Second, removal of outliers. An outlier means any invalid data in the dataset which is not relevant for our program. Referring to our previous example, suppose the exam is to be conducted on only 2 units, but the question bank consists of 5 units. Then, the remaining 3 units can be labeled as outliers. Next, we have to handle any imbalance in the dataset. By imbalance, it is implied that one kind of data is more frequent than other kinds of data. Going back to our example, if there are 50 questions for Unit 1 and only 10 questions for Unit 2 in our question bank, the student is trained to answer the questions of Unit 1 more accurately than those of Unit 2 in the exam. Now comes the crucial step of creating a model using the concept of convolutional neural networks, or CNN. Before we get into what CNN means, it makes more sense to understand what a neural network means. A neural network acts like a brain for the deep learning algorithm. You might know that a human brain consists of neurons which relay information to other such neurons. Similarly, a neural network, quite literally, is a network of neurons which process the data to reduce loss and train the model. A CNN, or a convolutional neural network, is a type of a neural network which deals with image and video data processing. We can also use pre-built architectures like ResNet 50 or Inception v3 instead of creating a model from scratch. The next step is to choose appropriate parameters for the created model. To clarify what parameters mean, we will head back to our previous example. In order to prepare for the exam, there are various approaches for different students. One student might be a visual learner, while some other student might prefer audio recordings for the preparation. Similarly, in our deep learning algorithm, our model has certain preferences or settings called as parameters, which help us enhance the performance of the overall algorithm. Here, a question arises: how do we know exactly which parameters are best suited for our model? One way to find out is by testing all possible parameters in the model and choosing the one which provides us with the highest accuracy. Such a trial and error method is popularly known as hyperparameter tuning. Finally, we train the model and test it for prediction by providing user inputs. Once the model has been trained, the user may only provide an image of something which seems like a man made structure, and the model will detect if it's a monument and further even recognize its name. The goal is to minimize errors and incorrect outputs and maximize accuracy and efficiency. It is equally important for the model to culminate all possible outcomes and display them by the order of their confidence meters. Not only that, but it is also preferable to integrate other outputs with the actual output and making the model realize the similarity between them. This uses the concept of integration of interpretability of the predicted outcomes. As elaborate as a deep learning algorithm seems, it also has a bunch of challenges up its sleeve. For one, a model, no matter how well parameterized, still sometimes tends to display incorrect outputs. As they say, to err is human. Hence, it is natural to assume a man made machine to commit errors too. Another challenge usually faced when attempting to deal with a deep learning algorithm is the time it takes for the model to train. The more the number of parameters and the more the number of epochs or training cycles defined for increasing chances of accuracy, the more time consuming the process of prediction is. Picking the model by saving its parameters and simply using it might help, but it's at the cost of accuracy. Images provided by satellite are often hazy due to atmospheric conditions. This hampers the accuracy of the model as the model cannot make our features of the monument as clearly as it should have. We will now describe briefly what technologies we will be using in our project. First of all, we will be using Python as our main programming language, as it provides us with many deep learning libraries like scikit-learn, TensorFlow, PyTorch, OpenCV, etc. We are planning to use the pandas and the NumPy module for pre-processing our dataset. Modules like Matplotlib, Altair, and Seaborn will be used for data visualization. Lastly, we will be deploying the deep learning algorithm on a Jupyter notebook, as it further can be deployed anywhere as per the user requirements. Speaking of future scope, using this deep learning algorithm, the accuracy obtained on this varied dataset is noteworthy. Also, it leads us to the fact that different landmarks can be effortlessly recognized using this classification algorithm. Therefore, for further research, we can invariably increase the dataset by adding monuments and structures from all over the globe. A full featured smartphone application can be prepared using the algorithm and pre-trained dataset. This application can act as a guide for tourists visiting these monuments or famous architectures. Also, if feasible, a computer tracker using Google Maps and Google Translate APIs can be integrated with this algorithm for engineering. A virtual guide that can help the people visiting a place where there are language constraints. Ultimately, our project strives to spread the importance of preserving and maintaining the information of our cultural heritage digitally. Thank you.